Welcome to today's video. In this video, we are going to solve one more Geek for Geek question. Actually, I did not find this question in lead code, or it might be in some premium under premium section. So I did not find it. So we will solve the same question in Geek for Geeks. Okay. So rat in the maze problem one. So I have some advanced rat maze problem also that I found in lead code. So let's first understand this basic problem. Once we are going to deal with this, then we are going to move to advanced version of this problem into the next video. Okay. So let's first understand this question. So it's a very good question. It has been asked in multiple companies, big companies like Adobe, Microsoft. I've heard that. Okay. So let's understand this. So here given, consider a rat placed at the position of 0 and 0 at n cross n matrix, and the metric name is mat. The rat goal is to reach the destination n minus 1 and n minus 1. Since it is n cross n, so the last index of the matrix will be our destination, and the rat can move to four possible directions like up, down, left, and right. Okay, the matrix contains only two possible values. 0 means it's a blocked cell, and 1 means it's free and rat can pass through it. Okay, your task is to find all possible path that rat can take to reach the destination. So we need to take these valid directions and go to the destination. Okay, and under the condition that rat cannot revisit any cell along the same path, so we cannot revisit the same path again. And furthermore, rat can only move to adjacent cells that are within the bounds of the matrix and not blocked. So rat can move at the only within the matrix, and we cannot go out. And rat can go to only valid cells, which is like 1 and 0 means, since 0 means blocked, so you cannot go to 0 cells also, and you can traverse only once any cell. Okay, and we need to calculate the path of all the valid solutions. Okay, and if no path exists, return an empty list. So yeah, so node return the final vector result vector in lexicographically a smallest order. Okay, so let's first understand this example. Let's first understand how we are going to approach this problem. So this is our rat maze where this is my entrance. So my starting point is the entry point. Let's mark the indexes. So my columns are like 0, 1, 2, 3, and my rows are like 0, 1, 2, 3. And this 0, 0 is the starting point, right? And this is like the last index, like 3 comma 3. This is my finish point. Okay, and we need to give the path, like all the paths from like how we can go from start to the finished position. So all the paths, right? So now in the question it has been given that we can traverse four ways. So let's understand this, what are these four ways means inside a maze. Okay, so here it has been said like we can go up. Okay, we can go down, we can go left, and we can go right. Correct. So what does it mean? Suppose we are over here, right? So our indexes is like 1 comma 2. So 1 is our row, correct, and 2 is our column. So now if I go up, my indexes will become 0 comma 2. So, and when I go down, my index will become 2 comma 2, right? So my columns remains the same. So whatever the column was there, so it remains the same, only I is changing. Correct. So when I'm going up, my I is getting decremented by 1, and when I am going down, my I is getting incremented, right? So what does it mean if I'm here and my I is here? So if I go up, my I will become, sorry, so if I'll go up, so my I will become I minus 1, and if I'll go down, so my I will become I plus 1. Similarly, if you come here, so now if I'm here like 1 and 2, and if I go this side to the left, my this index will become 1 comma 1, and if I go to the right, my index will become 1 comma 3. So if you see, my I remains the same, so my is still same, which is 1, but my index is like the column index is is changing. So when I'm going to the right, it is decrementing by 1, and when I'm going to the left, it is getting increased. So what does it mean over here? If my j is over here, so if I go to left, it becomes j minus 1, and if I come to the right, my j will become plus 1. Correct? So it's j plus 1. Correct? So now let's understand how we are going to traverse. Okay, let me just create one more maze. Let's mark the indexes like 0 1 2 3 and 0 1 2 3. Okay, so now if I'm over here, so now I have 4 choices. Okay, so I can either go to left or up or right or down. Right now, how to see like where we need to go. So if you see the conditions, so I cannot go up anyways, because this is the end of my matrix, right? So I cannot go up. So up got cancelled. Okay, now I cannot go to the left because this is my starting index and cannot go beyond this I, right? If you, this is the j and this is the I cannot go beyond 0, right? So our left also I cannot go. So now I can check whether I can go down or not. Yes, so I can go down. This is a valid state, so 1 I can go. Okay, so we will come over here. Since we went down, so if we are creating a path, okay, so we went down, right? So we can have a variable where we will store which path we are going to. Okay, now since we are over here, so again we can traverse to 4 ways, right? We can either go up, left, right and down. So these 4 places. So we can still go up because there are no constraint, because one is visited, we have not marked it like that, right? So we need to mark this as like we have visited this, otherwise we will go into the endless loop. So if it is not visited, we can again visit this. So to mark it as like we have visited it, what we can do, so I'll just clean this a little bit. So mark it as visited, what we will do, we will make it 0. Okay, so now we will make it a 0. Now we cannot go up, right? We cannot go left because this is the end. We cannot go to the up, we cannot go to the left, so we can go down. So this is a valid part, right? So since it's a valid part, we will traverse like this. So we went here, then we are going like this. Now again we went down, so we are going to add in our path D. Okay, and we are going to mark this as visited. So you can, I'm using 0, you can use any other number as well. So we will see like why I went with 0, because I don't have to add additional condition. Like we will anyways check like whether 0 is present or not. So if it is 0, the path is invalid, so I have marked it as 0. So you can use either -1, -2, whatever you want. Okay, now we are over here. Now here also we have 4 places to go. It is left, up, right and down. Okay, so now what we will choose, so up we cannot go since it is visited, we have a bound condition over here. So now we will check to the down. So down is 0, so we cannot go here also. So we are left with only 1, so we need to move to the right. So we will add, so we'll come over here, we'll mark it as 0 and we will add to the path R. Okay, so now we are over here. Now we also have, now we have 4 things to do, right? 4 places to go from here also. So we can either go up, we can go this side, we can go this side, or we can go down. Correct? So now if we go up, okay, so now this is also a valid path. We will mark it as 0 and we will go up. So this is a valid condition, right? So we are going to mark this as up. So we are over here, we'll mark it as 0. Now from here we can go either up or left or right or down. Correct? Now what will happen? So at this place we don't have any valid position to go. So we cannot go to the left since we have already visited it. Up is 0, right is also 0. Okay, and we are coming from the down place only. So we cannot go at any place. So what we need to go? We need to traverse back. So that's what we will use backtracking over here. So we need to traverse back. Okay, so here, so what we will do, we will mark this as again 1. So we need to revert this because we have marked it as 0, but we are not visiting it. We need to traverse back, right? So we will come over here. Now from here we cannot go this side, we cannot go this side, and certainly we cannot go this side. So what we will go, we will again go down. Okay, and we will mark this as 0. Since we went down, so this up is not valid, so we need to remove this and add a d over here. Sorry, it's d. Okay, so okay. Now from here we need to check from where and all we can go. We cannot go this side, we are coming from up, so we cannot go up. So we cannot go down since it's an end point. So the only place is we need to go to the right. So, and we'll mark this as visited. Okay, now we went to right, so we'll mark it as R. Okay, we'll add to the path. Now we are here, and now as we can see, like, we don't have any valid position in the up or in the left or in the down, so we have only right. So we'll add it to the right. So like this we have created a path like dd, ddr and drr. So we got one path, correct? In a similar way we will traverse all the path. So whenever we will encounter any roadblock like this, so where we don't have any places to go, so we will backtrack and then we will get on to the different solution. So now we come back to this, and we are going to write the same solution what we have discussed. Okay, so since we discussed on like what will be our like first, so we discussed like our first thing will be our like, so we discussed our first thing will be our boundaries, our bound conditions, right? So we are going to have this. Now if second thing, if valid path, we are going to check that. Then we are going to mark as visited, right? Then traverse all directions and then revert back visited. So this is the 5 thing what we are going to do. Okay, so let's create first a helper function over here. So now we are going to remove this code here section. We are going to take we are going to create the results list. Okay, and we are going to create a new array list. Okay, now we are going to call our helper method solve, where we are going to pass our result, our maze, our starting index, which is always 0 0, and the length of our maze. Okay, which is like maze dot length -1, our like length and breadth both. So it is going to be same for us. So what we are going to do, we are going to create a variable. So we are going to create a variable for this. Okay, and we are going to pass only single variable, which is n. I think it should be enough. And we are going to pass the path. So I'm going to pass an empty string over here. Okay, now once we will call this solve method, we are assuming that we will get the results in our array, and we are going to return this our resultant list. Okay, now we are going to create one more method called solve, which is like private void. We are not going to return anything, and the name will be solve, and it will have my result. Okay, my maze. Okay, int like n int start index. Okay, so our current indexes I and j, int n, and string called path. Okay, so now let's add these things over here. Okay, now my bound condition. So what we are going to do, if our I is like less than 0, which is not valid, right? Or our I is greater than n, so anything, or my j is less than 0, or my j is greater than n, or my maze of I in j is equal to 0, which is like invalid, so we are going to return. So this is my bound condition, right? This is my prerequisite kind of thing. So I cannot, if this is any of these cases are there, so we are not going to traverse further, right? So see, like here we are using 0. So if we would have marked visited as like any other number, then we would have to add or condition and check like whether like it is -1, -2, or any other visited is there or not. So that's why I opted for 0, so that we can take care of in one go. Right, now if valid path, so what we are going to check, if our I is equal to n and j is equal to n, it means like we reached to the valid position, right? So here we are going to add in the result my path, and we are going to return. Okay, now since we came over here, so it means that maze is not equal to 0, right? Otherwise we would have returned from here itself, right? So we need to mark it as visited. How we are going to make it as visited? Maze of I comma j as 0. Okay, so we mark this as visited. Now we need to traverse in all direction, so we are going to call this solve method. Okay, now we are going to pass the result. Maze remains the same, I comma j comma n remains the same, and the path. Okay, so how many directions are there? So we have like 4 directions, right? So we are going to solve by calling in the 4 directions, 2 3 4. Now we are going to move up. So like I told you, if we are moving up, it means, so we are sorry, when we are moving up, so we are decrementing by 1, so we are going to append to our path as u. We are going up, right? When we are doing +1 to I, it means that we are going down, right? So we are making the path, we are appending to the path as d. When we are going to the left, which is like j -1, so we are appending l. And when we are going to right, which is like j +1, so we are going to append r. Okay, so we will traverse in the all possible directions. And now if any of the path is invalid, so we are going to revert my I and j back to 1. Okay, so we are not reverting any other thing. So if it would have been already 0, we would not have come over here. Since we are coming over here, it means that it was 1 earlier, right? So let's try to run this. Okay, so we got all the valid path. Now we are going to submit this. We got this error. So the problem is, I think it's the order. Okay, yeah. So you saw this note, right? Return the final result vector in lexicographically smallest order. So I think we need to short it, and then we can return the result. So what we are going to do, we are going to use collections dot sort method on the result, and then we can try to recompile this. So okay, let's try to submit this. So all test cases passed. Okay, so I hope you understand this. So in the next video we are going to do the advanced version of the same question. Okay, see you in the next. Thank you.